name is Professor Vinu. I'm a faculty for quantitative techniques in the Department of Logistics Management, St. Albert's College, Autonomous. Today, we will be discussing a very interesting topic from the subject of quantitative techniques, and that is binomial distribution. So, what is binomial distribution? A binomial distribution can be thought of as a simple probability of success or failure of an outcome in an experiment or a survey that is repeated multiple times. The binomial is a type of distribution that has two possible outcomes. The prefix bi means two or twice. For example, a coin has only two possible outcomes when you toss it. Either it could be a head or a tail. Similarly, when you take a test, there are two possible outcomes. Either you pass or you fail. So, binomial distribution has many instances that can be found in the real life applications. For example, if a new drug is being introduced to cure a disease, it either cures it, that is, the drug is successful, or it doesn't cure the disease, which means the drug is a failure. If you are purchasing a lottery ticket, for instance, you are either going to win a money in case you are lucky, or else you won't be getting anything, or you will not get any prize if you aren't lucky. So basically, anything you can think of that can be represented as a success or failure, we can use binomial distribution. Binomial distribution must meet the following three criteria. Number one, the number of observations or trials should be fixed. In other words, if you can only predict the probability of something happening if you do it a certain number of times. Second, there are only two possible outcomes. Third, each observation or trial is independent. In other words, none of your trials have an effect on the probability of your next trial. And last, the probability of successes is exactly the same from one trial to another. Let's look at some examples to understand this. Okay, so we have four statements. Okay, so the first statement is a telephone survey being conducted on a group of 200 people to ask if they have voted for Donald Trump. Second, counting the average number of dogs seen at a veterinary doctor's clinic. Third, if you take a survey of 50 traffic lights in a city at 3 p.m., whether the light was red, green or yellow. And the last, you are at a fair playing pop the balloon with 6 darts, and there are 20 balloons, 10 of which has a ticket inside which says win, and another 10 has a ticket inside which says lose. So now if you look at the criteria of putting a problem as either a binomial problem or not, the first thing what we should look is, we should understand if the number of observations is fixed. So in the first case, the survey of a group of 200 people to ask if they have voted for Donald Trump. Now if you look here, there's 200 people, so there is a fixed number of observations. So you are asking 200 people. Now the second statement says counting the average number of dogs seen at a vet's office daily. Now the average number could be anything, 50, 60 or maybe 100. Okay, so you don't have a fixed number of observations. So this cannot be considered as a binomial problem. The next one, you take a survey of 50 traffic lights in a city at 3 p.m. recording whether the light was red, green or yellow. Again, we have 50 traffic lights, so we will keep it. Okay, so we will not. So this may be a binomial problem based on the other criteria it satisfies. Okay, and the last one, you are at a fair playing pop the balloon with 6 darts. There are 20 balloons, 10 of them have a ticket. So here again you have 6 darts, so the number of observations is fixed. Okay, so you have here the last example, you have 6 darts. The example before that has 50 traffic lights and 200 survey people. So these are qualified to the next round. So the next question is, are there only 2 possible outcomes? So if you're doing a telephone survey to ask if they have voted for Donald Trump, the possible outcomes what you can get is either a yes or a no. So that qualifies it to continue in the race of a binomial problem. Okay. Now you take a survey of 50 traffic lights in a city at 3 p.m. whether the light was red, green and yellow. The outcomes, okay, it could be either red, green or yellow. So there are no 2 outcomes, it is 3 outcomes. So this doesn't qualify as a binomial problem. The last one is, you are at a fair playing pop the balloon with 6 darts. Okay, so when you pop the dart, okay, so the balloon would burst and a ticket would fall out. So the ticket could be a win or it would say a lose. So again, you have 2 possible outcomes. So we will keep it for the next round. The next thing is, each observation or trial is independent. So when you look at the first example, okay, so even if you call the 200 people, okay, so each one's response is independent of the next person or the previous person. Okay, so it's the responses of the next person is totally independent of the previous person. So that qualifies the third criteria. The last one, there are 20 balloons, 10 of them have a ticket inside that says win and the other 10 has a ticket that says lose. So this will, the observation of the trial would not be constant, because once you pop a balloon, the probability changes for the subsequent one. Okay, so this again doesn't qualify as a binomial problem. The last one is the probability of successes. Okay, the fail or pass, it remains constant throughout. So if you're doing a telephone survey, okay, so if you call a person, okay, so the possible number of outcomes is 2. So either if they say yes, the probability is 0.5. If they say no, again the probability is 0.5. So it remains constant for all the 200 observations. So this example qualifies as a binomial problem. So now let's look at the binomial distribution formula. The binomial distribution formula gives us the probability of the successes and failures. So it has 3 parameters. The first one is x, which is the total number of successes, which could be either pass or fail, heads or tails in case of a coin toss. The second is the parameter p, which says the probability of success in an individual trial, and n refers to the number of trials that you do. So it can be expressed mathematically as probability given that the total number of successes, number of trials and the probability of success on an individual trial equals to ncx into p raised to x into 1 minus p raised to n minus x, where ncx is the combination, okay, p raised to x is the probability of success raised to the total number of successes, 1 minus p is the probability of failure raised to n minus x, which is the difference of the number of trials and the total number of successes. So let's look at a problem to understand how this formula works. So 80% of people who purchase pet insurance are women. If 9 pet insurance owners are randomly selected, find the probability that 6 are women. So the first thing is we identify n from the problem. So using our example question, n is the number of randomly selected items. So we select 9 items, so that is n. The next one is we identify x from the problem. X is the number you are asked to find the probability for. So probability of success, so how many insurance owners are women is what we are trying to find, so that is 6. Step 3, we work out the first part of the formula. The first part of the formula is NCX, and it can be expressed as n factorial divided by n minus x factorial into x factorial. So when you substitute our values, it is 9 factorial divided by 9 minus 6 factorial into 6 factorial, which gives us 84. We will keep this number aside for a moment. Step 4, we will find P and Q. P is the probability of success and Q is the probability of failure. We are given the probability of success is 80%. So P is 0.8 and the probability of failure is 1 minus P, that is 1 minus 0.8, that is 0.2, which is 20% is the probability of failure. And we will work out the second part of the formula, which is P raised to X. So we know the value for P, that is 0.8 raised to X. X, we know it is 6. So 0.8 raised to 6 gives us 0.262144. And we will keep that aside for a moment. Let's work out the next part of the formula. So when we work out the third part of the formula, which is Q raised to n minus x. In our formula, we have written 1 minus P, which is same as Q. So Q is the probability of failure. So Q is 0.2 raised to n. N is 9 minus 6. So 0.2 raised to 3, that is 0.008. Step 7, we multiply our answers from step 3, step 5 and step 6 together, because that completes our formula, which is NCX into P raised to X into 1 minus P raised to n minus x. So when we multiply the values which we have obtained in step 3, 5 and 6 together, we get our answer as 0.176, which is the probability that out of 9 randomly selected people, 6 are women is 17.6. Okay, so that is how we solve a problem in binomial distribution. So thank you very much for listening.